Let's see if it works. So when we do this, it says I will relax a bit because it has detected that my account is actually not less than $100, right? So I will relax a bit. And the detection is very fine grained because the calculation is exact here. 100 is not less than 100. So it will still say I will relax a bit. Yeah, okay, so how to make it say work harder, I will work harder? Well, if it is 99, that would do. Okay, so work harder, I will work harder, the end. Can see that? Okay, now suppose, we notice the two forms now. One way to activate the if is if something, then do something. And that's it. Otherwise, don't care and continue with the sequence. There are cases where we want that. There are also many cases where we want if this, then that, right? If this is true, if my account is low, do this. Otherwise, do that. Okay, so this is the Y junction thing. And in its simplicity, that's what is being implemented in the sort of hardware uh, sequence. Now, we can build on top of this by saying what happens if I want to say I will work very, very hard if my account is less than 50. However, if it is more than 50 but less than 100, then I will work harder. But if it is greater than 100, I will relax. So that is done by using elif. So first check my account. If it is less than 50, then declare that money is very low. I must work very hard. Okay, so that's my statement. However, if my account is not less than 50, it has to be 50.10001 to higher up, right? So check again, and without the colon, sorry. So else check. So the elif is one word. Elif, notice it's purple color. It's a reserved word. Reserved words in Python cannot be used for any other purpose than just a Python command. Think of it as a command, right? You cannot use it as a variable name. You cannot use it as a function name. You cannot use it for anything other than standalone to instruct Python else. If that means check, right? Check. Otherwise, check my account. Is it less than 100? If it is true, at this point, my account is between 50 to $100. Why? Because if it had been 49, it would have satisfied the first clause, and so money is very low would have been printed. So if it is 51, it wouldn't satisfy this clause. Then it will sort of trickle down like a waterfall. It will trickle down to the next elif in a sequential way, right? So even inside a condition, you have sequence. Check if this condition is true. If it is true, then do what is inside. Then if not, what happens? You can have another elif, you can have a lot of elif, but you can only optionally have a final else. Okay, so we can remove this and it will still work, or we have this and have more. Let's run this one first. So when we run as it is, first of all, 99 is indeed between 50 to 100, so work harder, right? So we saw this. Let's try 49. Then it will be money is very low because it satisfies this condition and it executes whatever is there, right? And it will skip past the rest of the else, elif and else, and goes straight to the end. Notice that? Okay. And finally, it should of course work when it is larger than 100. And in this case, we see that it will skip past money is very low, work harder, and I will relax a bit. It will only do that because it is not satisfying less than 50, not satisfying less than 100, so it does this. Now, else does not require a condition. Else is basically a catch-all. That the condition that you're checking, if it's neither the if nor the elif, then I will relax. Then it will execute whatever is inside the else if the else is present. It's also optional. Okay, let's insert another elif. Is less than 200. Okay, may try to relax. So like I'm not sure. I think I'm having a little bit of a buffer money there, but maybe I can still work on, or I can relax. Think about it. But if you have more than 200, then okay, I will relax a bit definitely. So let's try that. So this time, because it's 109, it's not less than 50. So go to elif, the next part. Check. Is it less than 100? No. So go to the next part. Oh, it turns out to be another check, not yet else, right? Not yet else, and that's okay. So you can keep on having more and more elifs to sort of segment the range so that you can have appropriate behavior. It's almost like Python really looks at your account and gives you this advice. Hey, folk, you are running low in money. Can you work harder? Something like that. So, which is cool, right? Because although this is not organic intelligence, it is behaving like an advisor, like a consultant. Ever wonder how robo-advisor in finance manages to somehow really advise you to maybe you are too risky for yourself, your investment portfolio is too risky, maybe you should consider withdrawing some money from stock market and putting it into safe deposit, some sort of that, which is just done by this. That just done by this, right? So that if you have, can I have thousands of elif there? Sure, definitely. Okay, definitely. You can always pre-program it. The more elifs you have, well, it's not one to one, but generally speaking, the more elifs you have there, the more if statements you have there, the more checks you have there, the smarter, the more user-friendly, the more adaptable your program will be. So it is an indispensable kind of structure, logic structure in Python. Okay, so I hope that I've demonstrated in the principle behind which we first of all think about using if and how we do that and how we go from a need in real life when we are programming, we want someone to check that someone has to be Python, and the way we instruct Python to check is using if, elif, and else. Okay, now just last bit of demo just here. Okay, what happens if I have a lot of money? 209. Okay, so first of all, it will not be less than 50. It will not be less than 100. Skip past. It will also not be less than 200. Nothing. It will just print the end. See? Okay, so it is optional, but of course, optional doesn't mean you should do it because it doesn't sound very right. We should just put it back in. Okay, so I will relax a bit. All right, so that's the condition part. All right, and there are some examples here to show you how things work, but they are just basically given different context. So you can have numbers like 2 greater than 1, which is true if we ask Python, is 2 greater than 1? Answer is true, right? So you can then just basically be sure that okay, hello definitely will be printed and wow definitely will be skipped. And of course, this is very trivial. We never try to do a constant check. Constant is already known, so we don't do that. Typically, it is a variable. We don't know the result. It will be updated by user or some other systems or whatnot, compared with a fixed known value so that we know it is above, below, whatnot. Right? So that's the typical way. All right, condition, hello, and none. Okay, none is interesting. None is a special value in Python, which is emptier than empty, right? So none, you notice it is purple color. So it is a reserved word in Python. You cannot touch it. You cannot use none as your variable name, as your function name, as your module name. So none is the value that represents nothing. So it is a necessity in mathematics and computer science to allow us to say that nothingness is happening. Why? Because empty string is different from having nothingness at all. So empty string is nothing, no string, but it's a string. There's a string that contains nothing. 0 is a value, but it represents the concept of zeroness in mathematics, in number, right? It does not mean nothingness, because in Python, there are many kinds of different values: integers, floating points, strings. We'll come to that when we discuss about data type. Yeah, I'm going to do another video on that because it's a huge topic to understand how data, the new gold mine, right, in the contemporary business world, the new gold mine, right? So how data is being um, stored, processed, and represented in Python. So that's a very important topic. So just want to introduce the concept of nothingness. So true is true, a Boolean true. That means it's the state of being one state that is opposite from the state of being false. And instead of calling it black and white, yes and no, do and don't, Python just chooses true and false. That's okay, because so long as you have two labels. And notice again, true and false, they are in purple. You cannot use them for variable names and function names. Now, none is so interesting that can we ask Python, is none equal to 0? No. Right? Is none equal to empty string? No. Okay. Is none equal to true? No. Right? Now, if none is not equal to true, anything that is not true must be false, right? So we ask, is none equals to false? Here's where the big revelation comes. We would expect anything that is not true to be false. But none is this singularity, this black hole of nothingness there, that it is neither true nor false. It is just a third state that nobody touches, right? And this is essential because we need this notion of nothingness guaranteed by Python to be non-rewritable. So we cannot allow someone to say let none be equal to 1, because if any programmer can do that, then we are in horrible shape. It's like saying that suddenly the black hole is just a sun. It can emit light, and then that will be right. Everything is wrong, right? So we need a guarantee on that, which is why, even though it seems very trivial to us, none is a reserved word. You cannot redefine it. Okay, so just want to make sure that that is understandable, because when we do when we accidentally have none in our variable, yeah, then first of all, we can set that to be okay. Once we have none in our variable, what happens? Well, is none less than 50? No. Is none less than 100? No. What happens to this? Is none less than 200? No, because none is nothing. It's not less than 50, it's not what? So all we will get is, oh, something is wrong. All we will get is, let's try it out. Okay. Error because we are trying to compare none with integer, right? Because none cannot be compared. This will cause a very, very troublesome kind of meaning error had it not been caught by Python. So notice that Spider didn't catch any error. There's no red flag. And Python, only when you run will it be able to know that your Python, your variable called my account has got nothing, and it cannot be compared. So we can get weird errors if we accidentally or sometimes knowingly or wrongfully assert a none to a particular variable. Okay, so make sure that you have the correct value compared with the right reference value. Okay, good. So that's condition.